Now remember we were doing AC circuit, and I started from the very opposite side of AC circuit. Like first I discuss with you the resistor, inductor and capacitor. One question I told you about the parallel based AC circuit, that will definitely come in your midterm as well as in end term. Then I tell you about the power factor improvement. There are 90% chance that this type of question will come in your midterm again as well as in end term. Then I told you about the standard equation question. Standard equation question means V is equals to V max sine omega t. Then there is 80% chance that this type of question will come in midterm or end term. Okay, so this one is 100%. Power factor improvement question is 90%. Standard equation is 80%. Then we'll have the series based question, so uska chance is 70%. After this there is next topic which was left in the AC circuit, that is waveform based question. Okay, तो उसका chances is also like 95%. Almost हर पेपर में देते हैं ये waveform पे based. तो today I am going to tell you this waveform based question, and you can take printout of your PYQs and you can see the pattern which I told you. They also follow the same pattern, or the pattern which they follow, that's what I told you, right? तो देखे थे PYQs, देखे थे, इसी पे ही बेस्ड आया हुआ है, और इज देयर एनीथिंग समथिंग एल्स? मे बी एक या दो क्वेश्चन डिफरेंट आ जाए, बट पैटर्न इज अकॉर्डिंग टू दिस ओनली, बिकॉज मणिपाल टीचर्स नेवर चेंज देयर पैटर्न. लाइक अगर उनके 12 क्वेश्चंस आते हैं ना, तो 12 क्वेश्चन में 10 क्वेश्चंस आर फिक्स्ड, ओनली दे कैन चेंज इन 2 क्वेश्चंस. Okay, so this one I told you. Now I'm going to tell you about the waveform based question. See, for the waveform based question you need to learn the concept. There is RMS value and there is maximum value. So basically what is the RMS and the maximum value? RMS stands for root mean square and maximum stands for maximum only. तो रूट मीन स्क्वायर क्या होता है? लाइक सपोज दिस इज द वोल्टेज एंड एवरी इंस्टेंट आई एम मेजरिंग द वोल्टेज. ओके, at every point I'm measuring the voltage. Like suppose at this instant V1, V2, V3, V4 and up to so on, it goes up to Vn. So what is VRMS? VRMS is equals to root mean square, root and whatever the values we are getting uska mean, V1 square, V2 square plus V3 square plus so on Vn square divided by average. Root mean means average square. Okay, and maximum value is this one कि जो एक maximum value आ जाएगी. Now I am saying at your home you are getting the voltage is 220 volt. Now tell me, according to you, this 220 volt is the RMS voltage or the maximum voltage? Can you tell me? Because RMS includes all the voltage. RMS में पूरा they have covered complete ना. So 220 voltage is the RMS voltage. That's why I'm saying that in every calculation we have to use RMS voltage. Okay. So whenever they'll provide you the standard equation V is equals to V max sine omega t, we'll have V max. We need to convert it into VRMS, and we'll have the standard formula for this one is VRMS is equals to V max by root 2, or similarly I can write it down as IRMS is equals to I max by root 2. Okay, now after this sometime they'll ask you the two things. One is the form factor and another one is the peak factor. Form factor is denoted by FF and its formula is RMS value divided by average value. Peak factor is denoted by the formula peak value divided by the RMS value. That you need to learn this. I think this is mentioned in your handbook. I'm not 100% sure, but you can check it later on. This formula is mentioned in your handbook. So RMS, we can write down RMS, and I average is how much? What is the formula for average? Like RMS ka formula is I max by root 2, and average का फॉर्मूला इज 2 I max by pi. I भी हो सकता है, V भी हो सकता है. So for this I max would be cancel and answer will be pi by 2 root 2. तो इसको solve करके आती है 1.11 and this value is fixed. Okay. Similarly, we'll have peak value means the maximum value. Maximum value we can write it down as V max, and VRMS is V max by root 2. तो max से max कट गया, answer will be root 2 and root 2 is 1.414. So you can write it down in your notes also that form factor and peak factor, these are the fixed formulas and fixed values. Okay. Now after that, in this they'll ask you to calculate I average. So write down the formula for that. I average formula is alpha 1 to alpha 2 I dt over base length. I'll tell you what is base length and everything. We'll have IRMS. IRMS का formula is root of limit alpha 1 to alpha 2 I square dt over base length. This is the standard formula. Now I'll tell you what is basically base length, what is alpha 1 and alpha 2. Suppose we'll have the waveform like kind of this. ठीक है. First we have to see whether it's a symmetrical waveform or asymmetrical waveform. Like above one is the symmetrical waveform. We are having positive, negative पे भी will have output, positive and negative पे भी will have output. So this is a symmetrical waveform. But as in this case, you can see this is asymmetrical waveform. Why? Because we are having positive पे output है, negative पे output is not there. Again we are having positive output, negative output is not there, right? So this is symmetrical, this is asymmetrical. Now in this case, suppose it is varying from 0, 1, 2, 3, 4. It's in seconds. Let us consider this one would be time and this one would be I, that would be in current. Again this one is 0, 1, 2, 3. Okay. Now see what is basically will do in symmetrical and asymmetrical. ध्यान से सुनना. In symmetrical we'll take the output of this one only. क्योंकि symmetrical है, so we'll take the output of the half cycle, only positive cycle. But this is asymmetrical, so we have to take the output of this complete cycle. Positive भी लेना पड़ेगा and we have to take the negative one also. यहाँ तक clear है? That will have two kinds of waveform, symmetrical, asymmetrical. In symmetrical we need to take the half of the output and in asymmetrical we need to take the output of the complete cycle. ठीक है? Now see, as I told you, like if I want to take the output of this one, so in this case alpha 1 it is 0 and alpha 2 it is 1 because it varies from 0 to 1. So alpha 1 is 0, it is 1. Now base length is how much? Base length is this one. We have to take the difference, it is 0 to 1. So in this case base length is 1 minus 0. Okay. Now see, similarly for this case, in this case also we'll have alpha 1 is 0 because it starts from 0 and output comes up to 1. So alpha 2 is 1, but there is a change in the base length as we have to take the complete output. So its base length is how much? 2 minus 0. So in this case base length is 2 minus 0. So what is the main difference between the symmetrical and asymmetrical? In this case base length is only 1. In this case output हमें पूरा लेना पड़ रहा है, तो base length is 2. Write it down up to here. Okay, till now we got it. We got the value for alpha 2, alpha 1 and base length. Now we need to get the I. Okay, I is the current, and we can have two kinds of waveform, like we can have the slanting line, we can have the straight line, and we can have the decreasing line. So whenever we'll have the slope like this line, slanting line, this like this, then in that case we need to calculate the slope of this. And as you know, the formula for the slope is y minus y1. Like we have to make the complete equation basically, including slope. So what is the remember which you have studied in maths and school level? So what was the equation? Y minus y1, and the slope, then that is y2 minus y1 divided by x2 minus x1, and the equation is x minus x1, right? So the starting point is x1 y1 and the ending point is x2 y2, and you will get the equation in terms of y is equals to x की form में, right? Here the y-axis is the current. So in this case, later on we can replace y is current and x is the time. So after solving it, we'll get the current equation means I value, right? So now for this particular slanting line, like this is the output, right? Can you tell me what would be the equation for this particular line? Apply this equation wali formula in this and tell me, solve it. So with the help of graph, you can define the coordinates. This one is 0 0, this is x2 y2. X2 is how much? 1, y2 is how much? 5. So this is 1 5. So after solving it, we'll get y is equals to 5x. Y is the y-axis, that is I is equals to 5t, right? So we can substitute the value, we'll get answer. Like suppose I'm taking one more example that already comes in Manipal. Like you will get these kinds of equation. I'm telling you the standard way. Okay, now you can convert my way into the given equation. So that I'm telling you the complex one so that you can relate what I told you. Now suppose this is 10 volt, this is minus 10 volt, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is time in seconds, this is voltage. Here they whatever they can give anything. Okay, so in this they ask you to calculate heat dissipated. Okay, heat dissipated, and they provide you the value of resistor, that is 10 ohm. So according to you, as you know, heat dissipated formula is V square by R, है ना? So R को तो हम बाद में divide कर देंगे. We need to calculate voltage of all these waveform, right? Clear? Now what you need to do, you need first of all tell me, is this a symmetrical waveform or asymmetrical according to you? This is symmetrical, and as I told you, for the symmetrical waveform we have to take the output of the, मतलब इसमें half लेना पड़ेगा, but half is this one, right? हाफ साइकिल इज दिस वन ना. वी हैव टू टेक जहां तक तुम्हारी सिमेट्री जा रही है. हाफ मतलब ये नहीं है कि यहाँ तक ले लो. ओके, हाफ मीन दिस इज अ कंप्लीट साइकिल एंड दिस वन वुड बी, yeah, you have to take one symmetry. Okay, clear? Now as you can see that it is divided into three category. One category varies from 0 to 2. Here the output is 10 volt, right? Here the output is 10 volt. Okay, another vary from, like suppose if I'll say it is vary from 2 to 3, so I'm marking 2 to 3. Here the equation is the slanting line. Wait, first of the equation is वेरिंग फ्रॉम 0 to 2 दैट इज 10 वोल्ट. ठीक है, अब इसको ऐसे इंटीग्रेशन की फॉर्म में मत लिखो, आई एम ट्राइंग टू अंडरस्टैंड. एक मिनट. सो first it is varying from 0 to 2 second and the output is 10 volt, right? Then it after that it is varying from 2 to 3 second and the output is slanting line, means you need to calculate the equation by the equation method I told you, this one, right? After this one is, it is varying from 3 to 4 and that is completely 0, right? So that is 0. So now what our next step is, we need to calculate the equation for this line, right? So let's mark the coordinate over here. Here the coordinate is on the x-axis, x1 y1, right? We'll write it like in this form now, x1 y1. So x1 is how much? 2. y1 is how much? Minus 10, correct? Now for this particular case we'll have x2 y2. x2 is how much over here? That is 3 and y2 is how much? 0, right? Now can you tell me the equation? Solve it and let me know. After solving you will get this equation, y is equals to 10x minus 30, but I need to write it in terms of voltage and time. So V is equals to 10, I'll take common, t minus 3. Okay, clear? Now tell me, any doubt up to here? Now I'm summing this in the integration form as I told you. Like now I'm applying this formula which I told you. So they ask you, first of all we need to calculate voltage. So in the starting our limit vary from 0 to 2 volt, so it should be V square, right? So because पावर का क्या फॉर्मूला होता है? V square by R, so that's why it should be V square dt, right? So again limit vary from 2 to 3, so what we are getting, that V की value we are getting 10 bracket t minus 3, so we have to take the square of that, plus that would be 0 only, so I'm not writing, you can write it like this also, 3 to 4 0 dt, right? For this particular case 0 to 2 will have the value, that is how much? 10 volt, so it would be 10 ka square. Now if I'll solve it then it would be how much? 10 10 100, और उसको solve करेंगे we'll have 200. if I'll solve this one, ये पूरा integration को solve करके that would be 100 by 3, right? So if I'll solve this then it would be 700 by 3, correct? So this is the output of the 0 to 4. Now what we need to do, we need to divide by the base length also as according to the formula. So as I told you कि base length कहाँ से कहाँ तक लोगे, then we'll have 0 to 4, तो base length कहाँ से कहाँ तक आ जाएगी? 4 minus 0, right? So after applying all these formulas we'll get the voltage, total voltage, and after getting the total voltage we can get the power by dividing it by 3, or you can do it directly also, that it is moving from 0 to 8, that would be V square dt. So it would be, if you'll solve this, V 0 to 8 voltage you are getting how much after solving it? That is 700 by 3, correct? तो उसको solve करके whatever you'll get the answer, I don't know the answer, so I told you the method, ठीक है? See, this is the question from your question paper. In this they said a single phase voltage is 220 volt and frequency is 50 hertz, right? We'll have the motor drawing a current. Load 1 will have two load 1 draw power triangle. For load 1 will have load 2 draw separate power triangle for load 2. Okay, they said this load 1 is consuming current that is 12 ampere and cos phi is 0.76. So can we get power for this particular load? P is equals to VI cos phi, right? Voltage is 220, current is this one, cos phi is 0.76. We can get P1, right? If we have P1 and if we have cos phi 1, we can have S1 and we can have Q1, right? Clear? Because as you know, cos phi is equals to P by S. Now see for load 2, again we'll do the same thing. They said a single turn AC current I2 is 15 ampere and cos phi 2 is 0.61 lagging. So again we need to calculate P2, right? Because P2 is voltage is same, current is this one, cos phi is this one. We can get P2, and if we'll have cos phi, we can have S2 and we can have Q2, right? Now see what they ask, the total average active power and reactive power. So the total active power is how much? P1 plus P2, and total reactive power is how much? Q1 plus Q2. Okay, now if suppose they ask you the apparent power also, so don't do this. I'm writing down, don't do this S1 plus S2, never. लिख के काट दो. For this case you need to apply the Pythagoras theorem. So for this case जो ये PT आया है, total active power का square plus reactive power का square, because this is the new power triangle you need to make. For the new power triangle, this is the total active power, total reactive power, and total apparent power is always PT ka square plus QT ka square. Never do this S1 plus S2, because 95% of the student do this mistake, and this is a common mistake. Okay. Okay, so I was telling you that you need to calculate total active power is P1 plus P2, total reactive power is Q1 plus Q2. If they ask, they didn't ask in this question, but if they ask you to calculate total apparent power, you don't need to do this thing, okay? You need to do Pythagoras theorem. ठीक है? Now in this case, second part, they ask you to calculate capacitance is connected in parallel. Again this is the question of power factor improvement. तो दो power triangle बनेंगे. In this case, new case cos phi is 0.95 and ये total वाला लेना है यहाँ पे. Okay, so whatever you will have PT, whatever you will have ST, then you can get new cos phi, that is PT by ST. Then you will have QT and this one is Q2. Then again the same procedure, QT minus Q2 is equals to V square by XC. So we can get capacitor. Okay.